So in this example, we have x cubed plus x plus y cubed plus 3y equals 6. So how can we go about differentiating that? So to find dy by dx, we need to use something called implicit differentiation. Right, okay, so we know how to differentiate this first bit, this x cubed plus x. That's what we're used to already. So that would be 3x squared plus 1. But what about these y terms? I mean, we could sort of do the same thing, right? Well, yes, you can. So we've got to quickly do that. But after you've differentiated a y term, you must include this dy by dx, because you've differentiated with respect to y rather than respect to x. So for this 3y here, the derivative of 3y would just be 3. But you also need to include this dy by dx term. Okay, and then the derivative of 6, that would just get you nothing. After we've done that, we need to collect the like terms, so the dy by dx's on one side of the equation, and all of the stuff that doesn't have the dy by dx's, so the 3x squared plus 1, on the other side of the equation. So we'll quickly do that. So we'll leave the 3x squared plus 1 on this side of the equation. And what we'll do is we'll take all of this stuff and move it over to the other side of the equation. So quickly do that. Awesome. After we've done that, we can take a factor of dy by dx on the right hand side of the equation, and we'll get minus 3y squared minus 3. Okay? And in order to find dy by dx, we can divide both sides by minus 3y squared minus 3. Okay, right, we can tidy this up a little bit and we will have our answer. So we'll have minus 3x squared plus 1 over, and on the denominator we will have 3y squared plus 3. That gives us dy by dx, and that is essentially it. Okay, we're moving on to the next question. So now we've got y and x together in one term of the equation. So it's a little bit more difficult. So what do we do here? First of all, we need to differentiate each term, starting with the 4xy squared with respect to x, and then we add it with the derivative respect to y. So if you watch what I do, hopefully it will make a bit more sense. So if we derive 4xy squared with respect to x, what are we going to get? We'll get 4y squared. That's with respect to x. Okay? And then with respect to y, what will happen is we'll get 8xy. And remember, you have to include this little dy by dx term when differentiating with respect to y. Okay, so let's move on to the next bit, the 6x squared over y. Another way of writing 6x squared y would be 6x squared times y to the power of minus 1. That should make life a tiny bit easier. So let's differentiate this with respect to x first. So to differentiate with respect to x first, we keep the y to the power of minus 1 term the same. Okay? And essentially we times the power of x, which is the 2, by the coefficient of x, which will be 6 and then also the y to the power of minus 1, because it's the same. So that will give us 12 times x to the power of y minus 1. Okay, so let's move on to doing the y. We times the power, which is minus 1 on the y, by the coefficient of y, which is 6x squared. So that will be minus 6x squared times y to the power of minus 2, not forgetting our dy by dx, which is absolutely crucial. And then the derivative of 10, I believe it's 10, yeah, will be nothing. Now we need to collect our like terms together, our dy by dx's, by moving them onto the other side of the equation and all of our normal terms on the other. So that'll be 4y squared plus 12x y to the power of minus 1 equals, and on the other side we've got 6x squared y to the power of minus 2 dy by dx minus 8xy, and of course dy by dx. Awesome. Okay, so let's take a factor of dy by dx on the right hand side of the equation. We will have 6x squared y to the power of minus 2 minus 8xy. Okay. What we can do is equate it over to this side, the 4y squared plus 12xy to the power of minus 1. And hopefully it should be pretty obvious for what we should do, which is divide 4y squared plus 12xy to the power of minus 1 by everything on the right hand side to give us dy by dx. Right. Awesome. So that is the answer to that question. Let's move on. In the third example, we've introduced exponentials and logarithms. So first of all, we'll differentiate e to the 2x ln y with respect to x. So the ln y term remains the same. If we differentiate e to the 2x, well, that will be 2e 2x. And then the ln y stays the same, so we'll leave it. Okay, and then with respect to y, the e to the 2x term remains the same. And then the derivative of ln is just 1 over, it'll be 1 over y. So it'll be that. Remember our dy by dx because we differentiated with respect to y. And then that will be the derivative of x is just 1. The derivative of y is just 1. But remember, we have to include dy by dx. And then the minus 2 just eradicates itself. Let's get all of the dy by dx terms on one side of the equation and all of the normal terms on the other. So we get 2e to the power of 2x ln y minus 1 will give us dy by dx minus e to the power of 2x over y dy by dx. Okay, and then after that, as you know, we've got to factor out our dy by dx, which will be 1 minus e to the 2x over y. And of course, that is equal to our left-hand side of the equation. Okay, and for our final step, we have to divide the left-hand side of the equation by 1 minus e to the 2x over y. So let's quickly do that. Okay, and therefore that is our answer. For our last example, it's taking up a little bit more, but pause the video and have a go. Okay, So now I'm going to go through it. First of all, we derive the first term with respect to x. So that will be minus 3e to the minus 3x multiplied by y. And then we derive with respect to y. So the e to the minus 3x would remain the same, and the derivative of just y would be 1. So it'd be e to the minus 3x, remembering our dy by dx, and that solves the first part of the equation. So let's move on to the minus 3x, and really simple, there's no y term here, so that would just be minus 3. And then looking over at the y squared, the derivative of y squared will be 2y dy by dx. Cool. Okay, so now we take all of the dy by dx's, put them on one side of the equation, and all of our normal terms, that does not include dy by dx, onto the other. So let's quickly do that. So we'll get minus 3e to the minus 3xy minus 3 equals 2y dy by dx minus e to the minus 3x y by dx. And now we have to factor out our dy by dx. So that will give us 2y minus e to the minus 3x. And then we equal that over to everything on the left-hand side of the equation, which will be minus 3e to the minus 3xy minus 3. Awesome, so it's pretty easy. What we do now is we just have to divide all of this on the left-hand side and the right-hand side. So that will give us minus 3e to the minus 3xy minus 3 over our 2y minus e to the minus 3x. That will give us dy by dx. And then we can tidy this up a little bit because it doesn't look horrendous, but it's quite messy, and we can make it a bit clearer. So we can take a factor of 3 out of our equation, and we've got these negatives, remember, to deal with. So that will also change the denominator. So if we quickly do that, we'll get 3 times y e to the minus 3x add 1. And essentially what we can do is we can also times the denominator by minus 1 as well, because it will just be the same effect. So essentially we can pretty much do that, and that will give us our same answer for dy by dx as well. So it should be okay in this format, depending on the question, of course. Okay, so that's all the time that we've got for today, guys. If you found this video useful, please like and subscribe. Thank you.